So, environmentalists concerned about the impact of high frequency radio transmissions on birds found that there was no evidence of a higher mortality rate among hatchlings and nests near cell towers. They based this conclusion on a test using an alpha of 0.05. Would they have made the same decision at an alpha of 0.10 or an alpha of 0.01? Explain. So, some keywords: there was no evidence. So that means that they failed to reject the null at an alpha of 0.05. Meaning that the p-value was greater than 0.05. So then we want to know about an alpha of 0.1. So if it was if there was no evidence, so they failed to reject at 0.05, what would happen at 0.1? Well, if the p-value is greater than 5%, I want to know how the p-value compares to 10%. But we weren't told what it is. We were just told that it's greater than 0.05.
So we have to find it.
Well, no, it's just asking us a question. So if at 0.05 there was no evidence, so we failed to reject, what would happen at 0.1? Or maybe I say what could happen at 0.1. So either decision is possible. Because we have a p-value that is greater than 0.05, but that's all we know. So it could be less than 0.1, or it could be greater than 0.1 because we don't know what that p-value was. So then an alpha of 0.01, what would happen?
There would only be one decision.
Okay, what would that decision be? If our p was greater than 5%, now we're looking at 1%. What also is true? Is 5 greater than 1? So we would also fail to reject. So we would have the same decision.
I was going to say that.
The same decision because the p-value is greater than 0.01. We know that because it was greater than 0.05. So then, have harsher penalties and ad campaigns increase seatbelt use among drivers and passengers. Observations of commuter traffic failed to find evidence of a significant change compared to 3 years ago. Explain what the study's p-value of 0.17 means in this context. So, our null would be that the seatbelt use is the same as 3 years ago. Our alternate is that seatbelt use has changed, or more specifically, increased. So based on that p-value, would we reject or fail to reject, and why?
So no hypothesis would be. That's the p value. P value is 0.17, and it said the increase would be greater. Right.
Well, these are our two hypotheses. So I just need to look at the p-value and decide, based on the p-value, am I rejecting or failing to reject?
You would fail to reject
Why?
because it says it increases, so that's greater than. So the p value is greater than. So,
Well, I more do fail to reject because the p-value is not low. It's a high p-value. So the same stuff that like applied in the other chapters still applies here in terms of like the p-value and stuff. I don't know why it's like looks weird. So then to actually explain it, assuming seatbelt use is the same as 3 years ago, we would see sample results as extreme or more extreme about 17% of the time due to sampling variability. All right, so a report on healthcare in the United States said that 28% of Americans have experienced times when they have been able to afford medical care. A news organization randomly selected. You can just leave it up there. Thank you. I don't know where I was. A news organization randomly sampled 801 black Americans, of whom 38% reported that there had been times in the last year where they had not been able to afford medical care. Does this indicate that this problem is more severe among black Americans? Test an appropriate hypothesis and state your conclusion in the context of the problem. Assume all conditions have been met. So what would my null hypothesis be? P is equal to what?
P is equal to 0.38. Oh, 0.2.
Yep. And then the alternate would be what?
P is greater than 0.2.
Yep. Because it's more severe, so greater than 0.28. So then you can use your 1 prop z interval to find your p-value. There should be interval.
Was it? Are you sure it's not a test?
It might be. I don't remember what. I don't have it written down. I don't remember which one you plugged the thingy into, so it might be test.
Is that a cookie point?
Sure. If you're right.
So, that's 0.28. X is. Wait, it's an X and an N. I'll put 801 in X, right?
Wait, what does it ask for again?
The test.
Yeah.
P O X N, and if it's greater than or
I think X is the percentage, the 0.38. I'm pretty sure N is the sample size.
alright, that makes sense. Oh wait, it doesn't like the what's it called? The decimals, right?
Try it and see. I think it doesn't like it in the N value, which I think is what we had before.
Yeah, I don't
Okay, swap the 801 and the 0.38. Okay, hold on. 801 is in. X is going to be 38% of the 801.
Okay.
So 0.38 times 801 is going to be X, which is what's going here, which is where they don't like the decimal. And then 801 should go here and then greater than.
So that 304.38. Can I just say 304? Because it's a decimal.
Yeah.
You're looking for the p hat, right?
Yeah.
I got 3 approximately.
Wait, what is just P?
1.77.
Is there something at the end?
Oh yeah, eats the negatives.
That's what we're looking for. All right, so hold on. So you got P is equal to what?
P is equal to 1.77.
Okay. So that means P is basically 0.
I think that's the 10th cookie point.
It is. You have to tell them you got it for them. So this is obviously less than 0.05. Okay, so like an alpha of 0.05. It's less than 0.05. So do we reject or fail to reject?
No reject.
So we reject the null hypothesis. And what does that mean about evidence? Is there enough or there's not enough?
Not enough.
We reject.
There's enough.
So there is enough evidence to suggest ... You know, you can fill it in with what that means. I'm going to write this in really quick so that I have it. It's one prop z test. All right, so this problem gets continued on the next page. Get the cookie point so I don't forget. Yeah, now I owe 2 classes cookies.
Wait, algebra 2 beat us?
Yeah,
Oh.
they got theirs the other day. All right, so explain what your p-value means in this context. So this means that assuming 28% have difficulty accessing healthcare, we would see a sample with 38% having difficulty or more extreme. About 0% of the time due to sampling variation. So was your test left tail, right tail, or two tail, and why did you choose that?
I keep forgetting which ones. Hold on a second.
While you look, I'm going to refill my water.
It's right tail. It's right tail.
Is what?
Right tail.
Yeah, right tail, and why?
Because p-value greater than 0.
Yep, so it was a right tail, because it was greater than, and we chose that type because the rate had increased. All right. A local newspaper in a large city wants to assess support for the construction of a highway bypass around the central business district to reduce downtown traffic. They survey a random sample of 1,152 city residents and find that 542 of them support the bypass. Construct a 95% confidence interval to estimate the proportion of residents who support construction of the bypass. So remember, the formula for a confidence interval is the statistic plus or minus the critical value, which is the standard deviation of the statistic. Or we can use our handy dandy calculators and use 1 prop z interval. See, I had it right this time. And it'll be of x is 542, n is 1,152. I think I'm writing this in the right order. And then the confidence interval is 0.95. And then it'll give you out, as you would call it, a coordinate. Also, I saw what you did in Miss Greer's class yesterday.
That was fun. Me and Jake placed a bet. We were placing bets. I bet his lunch. He bet me snack. I had to buy. Said if I win, I get his lunch. If he wins, I have to buy him 3 snacks. We didn't finish the game yet, but
Oh,
we gotta finish that.
nice.
He's up by 20, so
Up by 20.
we're going to 160 game. That's like 5, 10, 15. So we'll see what happens.
You have the calculator. Yeah, she was trying to explain to me what y'all are doing because I was like, what in the world is that face?
Because I made a fart noise trying to strike.
That's funny.
The P hat is the coordinate.
I was like, I don't need P hat this time.
The coordinate is 0.44, comma, 0.5.
So then, based on the confidence interval, test the null hypothesis that city residents prefer to keep the business district as is. So that would mean that the null is to the residents do not want to bypass. Because they don't already have one, so we're not changing anything. So then the alternate is that the residents do want to bypass. Now, it didn't specify the p-value, so we're going to use 0.5 for this one. So p is equal to 0.5. And then p is greater than 0.5 for the alternate. So then do we reject or fail to reject? Why? Okay. Yeah. So if this went out to, do you still have this up?
Mm-hmm.
What was it to 3 decimal places?
3.
Yeah.
4, 4, 2.
And what was this one?
4, 9, 9.
So, technically speaking, oh no, I dropped it. Dropped the pencil. So, technically speaking, this confidence interval tells us that less than 50% of people, unrounded, want a bypass. So, because based on the confidence interval, less than 50% of the population want a bypass. Because 50% wasn't technically included in our interval until we rounded. So what is the significance level for this test? So we were told that we're using a 95% confidence interval. So that means that we're looking for the area where 95% of our data is. So that means that what's outside of the 95% is the other 5%. Okay. This was a right tail test. So the percentage that's left is 5%, but I only am looking at this area here, which means it's 0.025 or 2.5%. So our alpha significance level is 0.025 is what we're actually looking at. So the significance level is what's left outside of the confidence interval.
Ooh.
All right. Probably get through this one and then it'll probably be it. So, just a definition. A type 1 error is a false positive. So that means that the null is true, but we reject. A type 2 error is it's a false negative, meaning that the null is false, but we fail to reject. All right, so this problem is going to use that information. So, testing for Alzheimer's disease can be a long and expensive process consisting of lengthy tests and medical diagnosis. Recently, a group of researchers devised a 7-minute test to serve as a quick screen for the disease for use in the general population of senior citizens. A patient who tested positive would then go through the more expensive battery of tests and medical diagnosis. The authors report a false positive rate of 4% and a false negative rate of 8%. So put this in the context of a hypothesis test. What are the null and alternative hypothesis? So what is the null in words? I'll give you a hint. One of them is that they do have Alzheimer's, and one of them is that they do not.
So no, that they do not.
So the patient does not have Alzheimer's. The alternate is then that the patient does have Alzheimer's. So, in the context of this problem, what would a type 1 error mean? So that is that the null is true, but we reject. So how would we write that? So it's like it's a false positive.
Like in words?
Yeah. So I'll help with the first one, then you can do the second one. So the type 1 error is that the null is true, but we reject. So we would say that the patient does have Alzheimer's. Or wait, does not have Alzheimer's. I can't read. Does not have Alzheimer's. But the test says that they do. So they get a second opinion. And find out they're okay. Okay, and the second A second opinion could mean like the other tests that are run. It's just a shortened way to write it. And this is 4% have a false positive. So this is going to be 4% of the people. So what would a type 2 error mean in this context? I'll let you do this one.
The patient doesn't have Alzheimer's. Where, the patient does have Alzheimer's. But the test doesn't say that.
Yep. But test says they don't, and therefore miss the chance to get treated. So which is worse, a type 1 or a type 2 error? Oh, this was 8%.
Type 2.
Okay, why? What are they led to believe by having a type 2 error?
It's false.
So they're going to think that they're healthy. But they're not. All right, we'll save the last one for tomorrow. And then you'll have the rest of the time tomorrow to work on the problems. And then I'll probably explain what you're doing next week as well.